Good morning, colleagues and fellow researchers. Thank you for joining us this morning for this workshop. As it has been mentioned, my name is I'm Princess Masondo, and I'm from the School of Graduate Studies. I'm the statistician there, and I'm going to be facilitating the workshop. The theme of the workshop is quantitative research designs, and let me just see. So the outline of the presentation, I'm going to cover just to look at what is a research design. Since it's the theme of the presentation, we're going to look at different quantitative research designs. We're also going to look at some definitions of quantitative research. Then we're going to just switch gear and look at probability sampling, non-probability sampling, and we'll do some exercises. Within the probability and non-probability section, we'll look at issues around the population and the sample. So just to kickstart, I'm just going to take us through some, definitions of what can be perceived as a research design. Obviously, there are many different definitions, but I chose to just look at this one, which indicates that it is a plan, it's a structure, it's a strategy which guides you as a researcher. It guides you when you are writing your hypothesis. So it kicks in at the beginning, not at the end. So even when you are doing your hypothesis, as you are conceptualizing them, the research design, the type of the design that you are going to do is going to influence how the kind of hypothesis that you can do, or the hypotheses are going to influence the design that you can undertake. And similarly, the research designs, it guides how the actual study is going to be undertaken in terms of, for example, the methods that are going to be used to actually do the study. If the study is going to be done in a lab, if it's going to be done outside, whichever case, the design is going to give us a perspective. Actually, we can look into the future. When you say this is my design, we have an idea already of what is going to happen in your study. And similarly with data collection, we already have an idea. When we look at your research design, as you mentioned it, we already have an idea of, okay, because this study is in this particular way, this is what we're expecting. We expect this person to be collecting data in the lab because they've specified that this is their study design. And also, when you look at the research design, as you specify it, it also gives us a perspective on the analysis that can be undertaken once the data is collected. So the plan will also have the variables that will be studied. How are these variables going to be studied? And as I've mentioned, also in the plan, we're going to see how this relationship, these variables are hypothesized to be related to each other. So you can see it as a framework that serves as a bridge between the research questions and the execution or implementation of the research. So at the beginning, you conceive a topic. You conceive that there's a problem, there's a gap in this area. Then you formulate a research topic. Then you have your objectives as to this is what I need to study. But then the research design that you put across will form, it's a bridge between the questions that you have and the end product, which will be the results of your study, the responses to your research questions. So it is it's meant to guide you when you are answering to your research questions. There is that analogy of crossing a river. So it's likened to maybe crossing a river. You can look at it in that way, that there are many options that you can use to actually cross the river. You can swim, you can use a boat. Obviously, that is going to depend on if you do have a boat. So it's that kind of a situation where the design is giving us an idea of how are you going to cross this river of your research. There is no actually single best design. You can't really say this is the only design. However, approaches will depend on the inquiry you want to undertake. And also the design that you choose will depend on your knowledge, prior knowledge. What do you know in that area? You can also look at opinions or your previous experience and your worldview, how you view things. So you might find that you are a person who's more into feelings and those kind of things. So that is going to influence the design that you follow. And obviously then the design has to be the best one to respond to your research questions. But it's very important that you are very clear on the knowledge that you want to generate. It's very important that you are very clear on the research questions, because sometimes you do find that there is no clarity, even as the objectives are there in the proposal. You can find that there is no clarity. And once there is no clarity, it's going to influence also the design that you take. You might find that you take a design that is not appropriate for the study that you wanted, because the way the objectives were laid out, it was not clear. And also what needs to be clear, even when you put the objectives across, is to be able to be clear as to know where those phenomenons, where do they occur. So can I, for example, for this research question, can I use secondary data, which is data that is already there? Or for this research question, do I need to actually interview people? So it has to be clear, even when you look at your objectives, to say, this is where I'm going to get this data. As this research question is laid out, this is where I'm locating it. This is where I'm locating the second one, and so forth and so forth. And it also has to be clear. Let's say if you are using mixed methods, for example, it has to be clear even in the proposal that this objective, I'm going to respond to it through qualitative techniques. This one, I'm going to respond to it through qualitative techniques, and so forth and so forth. So that clarity is very important. So quantitative research, since it is the focus, it involves collection of data according to Crosssectional, so that information can be quantified. So the focus of quantitative data, how we collect the data, it has to be in a quantifiable way. We need to, it has to be numerical. So it's more about experiments and surveys and data on predetermined instruments that use statistical data. At the end of the day, when you collect quantitative data, the end result there is you are going to use statistical techniques to interrogate that data or to analyze that data. So it needs to be quantifiable. So it's numerical. It needs to be, you need to be able to manipulate it numerically. So that data needs to be, you need to be able to present it in a numerical way. And because it's quantifiable, the way we collect it in a structured way. The questions, the variables are properly structured. So what is a variable? Because this is what we'll be talking about. A variable is a factor which can vary or it can change. For example, we talk about gender. Gender can be a variable in your study. It assumes, if you measure this variable on me, you will find that it's going to assume a value of a female. If you measure this variable gender on someone else, it assumes a different value. So a variable is that kind of, it's a factor which can change or vary as you move across your observations. Similarly with weight, if you weigh me, I weigh 120, and you weigh the second person, they weigh 60. So there is that variability. It assumes a different role based on the unit that you are measuring. So your variables, they need to be clearly defined. and you need to be able to operationalize them. What do I mean by that? You do find that there are variables that you conceive, but you are not able to measure them directly as you have conceived them. So when you operationalize them, it's a procedure where you are able to say, this is a scientific concept, but this is how I'm going to collect it in the field. You will see with the example that follows. So we are defining measures or variables which are quantities of interest, or which serve as a practical substitute for the concept of interest. So you might find that you are interested in a particular variable, but practically you are not able to measure it. So then you might have a practical substitute for your concept of interest. So for example, suppose you want to measure well-being. So you can measure well-being through income, and you look at the different income categories, and then you can classify them and say those who are in this category A, from this group to this group, I will say they have this kind of well-being. Those who are in the middle group, they have this well-being, and so forth and so forth. Obviously, your definition has to align with what is proposed in the literature. You can also measure well-being according to Sen, who's proposing for functionings. So for example, instead of just looking at income, you can look at people's achievements. So for example, you can look at their health. You can look at their education, the level of education, life expectancy, and etc. So from those variables, you will be able to formulate a measurement of well-being. You will have to look into the literature to say, how do you use all these variables together to measure well-being? You can also look at it subjectively, and you also have the option of asking your participants to rate themselves as to if you have a category with what do you think? Do you think you have achieved the level of well-being that you've achieved? Then they can rate themselves. So you have to be clear when you do your objectives. You say, okay, I want to measure well-being, but perhaps I want to use, for example, administrative data, which is secondary data. So from this data that I have, how can I measure well-being? I wanted to look at it using income, but you see that in your data, there is no income. So maybe you can look at these functionings that are proposed by Sen. So it has to be clear how you want to measure it. That is also going to guide you as where you are going to collect the data, and also how you are going to ask your questions if you are going to do a survey. Another example is if you want to measure level of anger, let's say among teenagers, you can have a questionnaire that has been validated, a questionnaire that has been validated in the field that is used to measure anger. Or you can look at the loudness of the voice as they speak in a particular scenario or a situation, and you can measure the decibels. Or you can ask them to indicate their level of anger. So you can have a visual analog scale that you give them, and they indicate their level of anger on that analog scale, maybe on a scale of 0 to 10. So that clarity with regards to your variables is very important, because it's going to give direction as to which design you should take. Which design you should take, and how the data can be best collected. So broadly, there are three design schemes under the quantitative research. We have experimental design, we have quasi-experimental design, we have a non-experimental design, which are also called observational studies. I have to mention that under the experimental design, I'm not going to go too much into details in terms of how it's done, especially in the laboratory, because I decided to just look at things that are applicable in many fields, like in social science, in health, in education, as opposed to just looking at things that are only applicable in a particular field. So I just looked at it in a way that everyone will be able to relate to it, but not in, as it happens usually in the laboratory with the chemicals or with manipulating things in the laboratory in that way. So in terms of experiments, according to Blanche et al., we can say experiments are studies that seek to identify a cause-effect relationship. So the key there is we want to identify a cause and effect relationship when we do an experiment. What do we do in that experiment? We manipulate the independent variable, and it must be in a controlled environment. So it must be in an environment where you can control the other variables. You need to be able to control the experiment and the variables that are going to come into play into the experiment. You need to be able to account for every variable that is coming into play in the experiment. And then in that process, we observe the effect. So as we manipulate the independent variable, we observe what happens to the dependent variable, which is the outcome variable. So what we are interested in is an outcome response variable or the dependent variable. But we have an independent variable that we are manipulating. When we manipulate it, we look at what is happening at our dependent variable, which is our variable of interest. So as I've said, you manipulate one or more independent variables. So for example, let's say that your independent variable is, we can use pH level. So you look at, so as you change the pH levels, so when we are at pH level 7, you look at what happens to the concentration of a particular outcome that you are interested in. So you change the levels of your pH. Or for example, you can look at different treatments. So you look at, when I give you this vitamin, what happens to an outcome? If I give you this other one, what happens to the outcome? So I give you treatments, or if I don't give you anything and I give other people something else, what happens to the outcome? So that's what we mean by manipulating. We bring in a change in one factor so that we can look at the effect of those changes that we are making on the outcome variable. So one of the attributes of an experimental design, the first one is there has to be a manipulation of the independent variable, one or more independent variables. The second one is there has to be random assignment. So in the example that I gave, where I'm talking about, for example, treatment, we want to see what happens to your blood pressure when we give you this treatment as opposed to a standard treatment. Let's say there is a new treatment that we want to look at to see how it affects your blood pressure. So we give one group, which we call the control group, we give them a standard treatment that is currently existing. So it's a treatment that we know how it performs, but we want to see how it performs against a new treatment. So one group receives the standard treatment and the other group receives the new treatment. Then we look at the blood pressure in those two groups. So randomization is about how people are allocated to those two groups. As I've said, you have two groups in the example that I'm using. One is receiving a standard treatment, another group is using a new treatment. The one that is receiving a standard treatment, we can call it the control group. And then the one that is receiving a new treatment can be the experimental group or the treatment group. So randomization is about how are we going to assign people to this treatment. When you assign things randomly, I think the example that will be clear, even though it's not always practical, but when you want to select things randomly, let's say I have 50 units and I want to select them randomly. So I put them in a box. I put those units, let's say I will label them 1 up to 20. So I take those 20 units, I put them in a box, and then I shuffle, and then I will select 10. The first 10 that I take out, I will give it to the control group or the treatment group, and the next 10 that I take out, I give it to the other group. So in that way, I've tried to randomize. I've tried to ensure that the people that I'm assigning to the group or the observations, the units that I'm assigning to the group, they don't differ systematically. I don't find that in this group, I've only put older people, and in the other group, I've put mostly young people. What randomization does, it ensures that there are no systematic differences. Everything is random. So randomization also is used to, it ensures that we control for co-founding, which are variables that we are not interested in. But if we don't randomize, those variables can affect your response variable. Remember, let's say with the example that I used, you are saying you want to see how this treatment affects the blood pressure. So if there is another variable at play, then you will not be able to say that the improvement or the drop in the blood pressure that I'm seeing is because of this treatment, because there was another variable at play which influenced your response variable, which is not what we want. What we want is to be able to say that the difference that I'm seeing, whether it's an increase or a decrease, is because of this treatment that I applied, but not any other variable. Also, randomization allows us to use statistical techniques for the tests that we would want to do in order to look at our hypothesis in terms of we have enough evidence to accept our hypothesis or to reject it. So as I've said, as we randomize, we manipulate the dependent variable, but we carefully observe the dependent variable. So if an experimental design is actually done properly, we have enough evidence to claim causal relationships between the variables that we are looking at. So I've mentioned that randomization assists us to ensure that we can minimize co-founding. A confounding variable is a variable that it co-varies with the manipulation of the experimental variable. So it undermines the validity of the experiment because we want to be sure that the effects that we are seeing, this increase or this drop in blood pressure, is because of this experiment that we have undertaken. It is because of this treatment. So co-founding, if we introduce another variable, then we won't be able to say that the drop or the increase is because of the treatment that we did. So in another way, it masks or it distorts the relationship between the measured variables in a study. So we are not able to say that a change in the dependent variable is actually due to is not due to the other independent variable that we didn't measure, because we are only measuring two variables, but there could be other variables. But when we randomize, we are able to control for that. So then we are able to say that the results that we are seeing, they actually reflect the true relationship between our variables of interest. I will use this example to actually explain this concept of co-founding that I'm trying to explain. So suppose you want to determine if online workshops are better than face-to-face workshops for UNISA postgraduate students. So what do? You do an experiment where you have some students, they attend face-to-face workshops, and then you have another group attending online workshops. And then you allow the students to actually choose which workshop they want to attend. And then after they've attended the workshop, it's a one-day workshop for both the people who are in the online and who are in the face-to-face. And then a day after the workshop, what do? You subject them to an assessment. What do you want to, at the end of the day, you want to try and say if the people on the online workshop do better than your traditional face-to-face, then you want to make claims that online workshops are actually better than face-to-face workshops. Maybe your assumption is maybe because they are recorded, people have a chance to actually listen to them over and over again. So maybe they are more efficient than your traditional face-to-face. So in this scenario, the outcome that we are interested in, which is the dependent variable, is assessment score. And the independent variable is the workshop type or the workshop group. It's either you are in the traditional face-to-face or you are in the online group. So I've already said, so the control group will be the face-to-face, which is what we are accustomed to, and the treatment group would be the online group. So in this exercise that I've put, potential co-founding variables, the variables that can distort the picture, it's age. Since the students are selecting the workshop that they want to attend themselves, you might find that younger students enrolled mostly in the face-to-face workshops, maybe because they have time. And you find that your more mature students opted for your online version. So there is that variable that kicks in now, because now these two groups are no longer, they don't differ systematically. They differ systematically, if I can put it that way. They differ in terms of age, because the way the allocation was done with a voluntary selection, it ensured that there are differences in age. So now age becomes a confounding variable. It might distort the picture. Another variable can be that the people who select face-to-face are maybe full-time students who are bursary students. And by virtue of them being bursary students, we can assume that they have more time and they are high performers because they are bursary students. So you find that in your face-to-face, you have more bursary students who have time and who we can say they are high performers. So already that group, it's already advantaged. You won't be able to say that if you find that face-to-face learners, or the learners, they do better than online. Are you going to say it's the treatment, it's the nature of the workshop, or is it because you had these students, this kind of students with these attributes in that group? So that variable now, So this variable that I've presented, it masks the true relationship between what we're interested in, which was the effect of the workshop on performance in terms of how much knowledge they are going to retain. And the other one could be, the last one could be, maybe, for example, you might find that your more matured students, maybe your PhD students, enroll into online workshops. And the matured students, they have experience. They have done this in their master's studies. So they have an advantage over your entry students. So if the people on the online treatment, if they do better, is it because online is better, or is it because you had more mature students in that group? So that is what we mean by a confounding variable. It's a variable that comes in. You didn't measure it, but because you didn't randomize when you were allocating your people to the groups, that variable comes in and you cannot control for it. You cannot measure it. It masks, it distorts the picture. At the end, you are going to make wrong conclusions and say online treatment is better, whereas there was a variable at play, which was the maturity of a student, which you didn't measure. So that's what we mean there. So randomization, I've explained randomization. It's a way of assigning subjects or participants to experimental group in an effort to make the group, we want the groups to be equivalent. There shouldn't be systematic differences, as I've explained, with the systematic difference in terms of age or in terms of level of maturity as a student. So those are the variables that you didn't directly observe, but they are there, they are affecting your outcome variable. So randomization ensures that the two groups are similar in terms of their characteristics. If you go back to the example that I used of putting their names in a box and just randomly selecting 20, you put 20 on there. So to make the study better, what you could do is you could say, here is a workshop, we want to do a study as UNISA, and then what would we do? We would randomly assign some of you to online and randomly assign the other group to face-to-face. Maybe that's when we have problems with experiments, because that might not be suitable for both of you. So what comes into play there with experimental designs is that as you assign treatments, there are ethical issues there. That's why experimental designs are not always feasible, especially when it involves humans. If your treatment that you are giving is better, if we use an example of, if you are using students, undergraduate students, and you say, for these 6 months, I'm going to put them on this new teaching approach that is the best, and I have a control group that is using the old approach. Obviously, if this approach is really good, the people who are on the treatment group on this new approach, they are more advantaged. They are going to do better come June when they write the assessment. So withholding the experimental treatment, it can have ethical issues. So you need to also to manage that and say, maybe I can't do it for 6 months. I have to do it for a month until I see a little bit that there is light, because you are withholding the benefits of this treatment to the other group. As I've said, yes. So it overlooks the potential need for some individuals to benefit from the treatment. You have to think about, when are you going to conclude an experiment, and you have to decide whether the experiment will provide the best answers to a problem. And you also have to think about the risks and the benefits. Obviously, the risk of the experiment that you are doing, especially when it involves humans, they have to outweigh the harms that can be potentially incurred. So experimental designs are well suited for testing hypotheses, well-defined concepts, for descriptive studies rather than for exploratory study rather than descriptive, and for laboratory or natural experiment. And then we move on into another design, which is quasi-experiment. So quasi means resembling, meaning this design, it resembles an experiment, but it does not have all the characteristics of an experiment. So it is characterized by the following. You don't have random assignments of participants to the independent variable. If we go back to the example that I used of the online workshops versus the face-to-face workshops, there was no randomization there. It is an experiment, but we cannot randomize, maybe for ethical reasons. But we do have a treatment there, which is they're all giving them online and giving the face-to-face, but there is no randomization. So it's missing an aspect of a true experimental design. And in some cases, we opt for a quasi-experiment because we cannot randomize. For example, for ethical reasons, sometimes for practical reasons. For example, if your variable of interest is gender, you cannot assign people to a gender. That attribute is inherently there in them. So you cannot randomize. So this kind of a design, by default, you would have to do this particular design. For example, if you want to look at, let's say you want to look at IQ scores of grade 1 learners, and you want to compare males and females. So you cannot randomize there. You just have to take the males and measure them, the females and measure them, and then compare. And another example is if you want to look at whether poor nutrition affects eyesight. So you cannot subject people to poor nutrition. It would be unethical. And then you give the other group very good nutrition and then look at their eyesight, compare how the eyesight performs. It would be unethical to put people into a group of poor nutrition. So a quasi-experiment is done usually because the groups, they allocate themselves naturally, as I've used the gender example, or it's not really ethical in that particular situation to randomize. These are some examples. I'm not going to go through them because of time, but these are some examples of a quasi-experiment. I just want to come to this example here. So suppose that you want to study the impact of a new psychological therapy on patients with depression. So half the patients, for the study to be, so you can take half the patients are assigned to receive a new treatment, and the other half, they receive a standard course of treatment. So here I just want you to see the difference between if the study is truly experimental and when the same study is truly quasi-experimental. And then what you can do is you can let the patients complete a sheet weekly where you measure the symptoms of stress or depression, rather. So you assign them randomly to the two treatments. The other one, they receive standard, the other ones, they receive a new treatment. But if you do the study as a quasi-experiment, it can be argued maybe that, say, the owners of that facility do not agree that you randomize the patients to the treatment. So what can you do in that way? Maybe you find that there are psychotherapists within the clinic who are trying out the new therapy on their patients, and then you still have those ones who are using the old standard treatment of depression. So you can use those groups already. They are there, they are existing. You have this psychotherapy already has patients on this treatment, and then you have the other group where they are using the old treatment. But it might be difficult for you to, if you use now a quasi-experimental design, it might be difficult to say that the improvement in that depression is because of the new treatment. Because you might find that maybe the people in the new treatment are people who are exercising, and we know that exercise can improve your stress or your depression levels. Or the people in the new treatment are people who take care of themselves in terms of their diet. They eat well. So that is going to, so at the end, you conclude that this is because of the improvement in the depression is because of the new treatment. However, there are these variables that if you are using, for example, here we are talking about a questionnaire or a sheet that they are completing, to make sure that you account for these variables that are going to mask your studies. You can also put those variables in the questionnaire. And then in addition to looking at their stress levels or the depression levels, you also ask them some background questions. You look at if they are exercising and how often, and you look at their, their behaviors in terms of diet. So you include the variables that you believe can affect depression. So you include them in the questionnaire, and you will be able in that way to control for them. You might not be able to control for all the variables that affect depression, but you might be able to control for others, so that at least you reduce their role in masking the true what the true effect of the treatment. Back to these exercises. And then finally, within the quantitative designs, I've said we have three broadly. We have non-experimental design. The first one was an experimental design where there's randomization and there's manipulation of the independent variable, and you observe the dependent variable. The second one was a design that looks like an experiment, but it lacks some of the attributes of a true experiment. For example, it doesn't have that randomization. Then the third one that we're looking at is non-experimental design. In a non-experimental design, a phenomenon is observed as it naturally occurs. There is no intervention or a treatment that is instituted. So those two characteristics, there's no treatment, there's no randomization. They are appropriate when the purpose of the study is descriptive, when we want to look at explanatory hypothesis, or when it's not possible to manipulate the exposure that is being studied. For example, if the exposure is potentially harmful and cannot be ethically assigned to participants, you won't be able to do an experimental design in that way. You just have to observe the phenomenon as it occurs. Within this group, we have cross-sectional studies, which involve the collection of data from your participants at one point in time. So data is collected on one occasion. So the outcome variable, which is your dependent variable, and the independent variable, the exposures in the study, they are measured at the same time. All the variables that you want to correlate in your study, you measure them at one point in time. Your participants are selected just based on the inclusion and the exclusion criteria. You don't select them based on they have, for example, they already have the outcome that you are interested in. No, you just go there, you measure if they have the outcome and if they have the associated risk factors to that outcome. So for example, if you want to measure the prevalence of gender-based violence in a particular geographic area, you can design a survey and you can develop an instrument or use an existing instrument that is validated to measure violence or gender-based violence and its associated factors. So you are looking at the prevalence of gender-based violence at the time, and you are also at that point in time able to measure the risk factors. You ask them, if they are their education level, if you believe that education level is is linked to gender-based violence. You ask them their socio-economic status, you look at their income, if they are working, and all those things, which are supposedly from your literature, you've identified them as risk factors. So you are able to measure the risks and the outcome of interest at the same point in time. At the end of the day, you are able to say, this is the rate of gender-based violence, and you are also to report on the factors. On the other hand, we have longitudinal or cohort studies within non-experimental designs. So with your longitudinal or cohort studies, you're collecting data from your participants at more than one point in time. So when you contrast it with the one that I've mentioned, cross-sectional, where with cross-sectional, you collect once. I come, I collect, the study is done. With this one, I have to collect more than once. So we have two types within this longitudinal studies. We have retrospective, which means we look into what has happened. So the dependent variable has already been affected by the independent variable. The outcome that we are interested in has already happened. And then now we look back to see what happened. So for example, if you look at people, let's say you are looking at someone who has been, who has gone to maybe another stage of cancer. So you are going to look back and see from maybe medical records, the risk factors as the person was coming for checkup and they were collecting variables. Then you can look back and see this year, this is what was recorded, or this year, this person went through chemotherapy, and then in the second year, they went through, then they went into remission in this year, and that, and so forth and so forth. So you look at the back, this person is now on stage 4, let's see what happened. And then you take what has happened, you are trying to link it to the outcome that you are seeing at present. And then the other side of it is you look into the future. So you have people who have an outcome, you have people who have some risk factors. So you look at people maybe who who are not exercising, who are not eating well, and you follow them and you want to see if they will develop a particular disease in the future. So you follow them until they experience that outcome of interest. Let's say you are interested in when they will maybe be diagnosed of high blood pressure. So they have risk factors now, but they don't have the outcome. You follow them until they have the outcome. So I'm using this example. Most of my examples are in the educational setting because I believe you'll relate with them. So suppose you want to determine time to completion of a 3-year degree at UNISA. So this is your study. I want to determine time to completion of a 3-year degree at UNISA. So you have two options. You can follow different cohorts of studies. So you can say, okay, this is 2021. I'm going to now, I'm doing the study now. I'm going to look at the students who register this year, next year, the following year. So maybe all 5 years from now, including this year. I'm going to follow these students until they experience an outcome. What is the outcome? The outcome is completion or graduation. So you are going to follow them until they experience the outcome of interest. And then you will decide on how long you are going to follow them. I know with your universities, like your normal university, where you attend, you have your face-to-face contact. Usually the studies, they will follow them for 5 years. And then those who graduate within the 5 years, you can report that in the 3rd year, I had so many graduation, 2nd year, and then you can also report on the associated factors. With the second option, what you can do, you can say, okay, I'm doing my master's. I don't have time to do a prospective study and look into the future. because I don't have 5 years to do my master's. I only have a year or two. So my only option, I really want to study this topic. So my only option is to look into what has happened. So you do a retrospective, you study now, you look at the problem retrospectively. You use administrative data to analyze time to graduation of students. So you go into the database and maybe start from what happened in 2015, students who registered in 2015, and then from the administrative records, you trace them until graduation and maximum until 5 years, and you are able to report. The advantages of using this first scheme, which is look into the future, is you'll be able to, that data doesn't exist, so you can give them a questionnaire. You are in control of the variables that you can put in the questionnaire. So the variables that you get from the literature as your risk factors, you can put them in the questionnaire. For example, variables like time management, if your literature says time management affects how students perform, motivation, so those variables you are not going to find them in a database. In the database, you're just going to find my age, maybe how I performed in matric. Yeah, you'll find some attributes, but you're not going to find everything. So the advantage with scheme A is you're able to add variables. The disadvantage is because it's now you are subjecting them to a questionnaire, some students might not be willing to participate. So you will have your sampling issues, and then you might have sample bias. So you might find that the students who are willing to participate in your study are the students that maybe are already experiencing problems in their studies, or it's students who are attending, for example, support programs. So you know, universities have support programs, mentorship programs. So maybe you find that the students who are willing to participate in your study are the ones who are attending those programs. So there is sample bias there. Those students, we can say maybe they are more advantaged, but your sampling is biased. And there's sample attrition problem with that kind of a scheme where some participants will decide not to continue with the study. So you will lose some of your participants along the way as you pursue your 5-year study. And it can also be costly because every year you have to be printing questionnaires and sending them, maybe because online you are not getting good responses, so you are opting for paper. It can be costly in that way. If we look at option B, the advantage is it's easy to implement. The data is already there. It's easy to implement. You don't have to recruit people. The disadvantages is going to be that you have limitations with regards to the variables you can include in your study. You can only include the variables that are already there in the database. So when it comes to those variables that we talk about there, the co-founding variables, you might not be able to control for those co-founding variables that might come into play. So for example, let's say from the literature suggests that being a first-generation student puts you at risk of taking longer to complete your qualification. From the database, you are not going to be able to get that variable. I think back in the days, that variable used to be captured where when you are applying, they would ask you, you know, the level of qualification of your parents, your mother, if it has matric or if they have a degree and all those things. But I don't think it's still being done now. So if you have a variable like whether a student is a first generation student or not, you won't be able to measure that in your study. So it's got those limitations. Another example of a longitudinal study, it's a study that is done by Statistics South Africa, which is called the Living Conditions Survey. The survey, the main aim of the study is to identify and profile poverty in South Africa so that policymakers can have information on who is poor, where the poor are located, and what drives poverty in the country. That information is also collected so that they can update the CPI basket. We do know that there is the consumer price index, which gives us an indication of whether the prices are increasing or dropping, the prices of the goods and services that are consumed by most South Africans. So the decision as to which the goods and services which must go into the basket is based on this study. So how this study is conducted, which is what I want to bring you to, is that it's a longitudinal study. It's done over 12 months. And if you are sampled to participate in the study, you are given a questionnaire and you are given a diary. As part of the diary, you have to record the things that you are buying. That I bought tomatoes. 4 tomatoes, I bought them for this much. Every day you record what you are purchasing. You record what you are consuming. You record that you spend money on transport. So that data, it's longitudinal. It's more than one set of data for one participant. And then we have another example, which is a case control studies, which fall within this non-experimental design. So we are looking at your current outcomes and your past exposure. So you have an outcome now, but we look at what exposed you to this outcome that you are having now. But we assign cases to one group. Is a case that has the outcome, this is the group that we have identified. These are people who already have this outcome of interest. Then we must look for another group, which is similar. They have to be similar in attributes. Let's say their age, their weight, if weight can affect that thing. That does not have that outcome of interest. So we have 2 cases, the control, which does not have the outcome, and then we have the cases, which are the people who have the outcome. This is used usually with studies where we want to look at rare occurrences. So you are not able to look at the full population because these things are not experienced by everyone. So you target the people who've experienced them, and then you compare, and then you look at their exposure backwards. What was their lifestyle? What were they doing? And then I compare them with another group which doesn't have the outcome, and I also look at the exposure. So what if the exposure is found more commonly in the cases than in the control, then we can say that exposure is linked to the outcome of interest. So for example, if you want to look maybe at rare cancer, like thyroid cancer, so at a particular point in time, you have 20 patients. You've managed to find 20 patients who have this rare cancer, thyroid cancer. And then you look for a group that does not have the rare cancer. And then you look at their previous exposure. What exposed them to this rare cancer? For example, maybe let's say literature suggests that radiation can put you at risk of having thyroid cancer. So as part of the previous exposure that you are looking at whether this person has had another cancer before, if they've been through radiation, and all those things. So that is a case control study. So in summary, cross-sectional, it happens now. We collect data now about the exposure, about the outcome. Prospective, we have the exposure. We follow the people into the future until they get the outcome of the interest. Retrospective, we have the outcome. We look back at what exposed them to this outcome that we have. And then case control study, similarly, we have this group who have this outcome. It's a rare occurrence. We find another group which doesn't have this outcome. Then we look at their exposure, the previous exposure. So this is just a summary that you can go through. It covers some of the things that I've mentioned there, but it also includes some of the statistical techniques that you can apply with this different study design. I'm going to end there with this part of the presentation, and I'm going to ask my colleagues to take us through the example that the two exercises that we are going to do as part of just re-emphasizing the concepts of what we are trying to learn today. So it's exercise 1, exercise 2.
Yes, from exercise 1, I picked up two responses. The first one is saying quasi-experiment is not a true experimental design and there is no randomization. Students are divided into groups. So the first one ends there. Should I go to the second one?
Yes, you can continue.
Okay, the second one, what makes this a quasi-experimental? The education or intervention to only classes in the experimental classes. So the dependent effects of educational intervention, independent high school students, independent variable manipulated with education and knowledge control group. Okay, let me see. Then there is yes for randomization, and there is no. They were assigned by the classes, and in South Africa, classes are often assigned by academic performance. How can you make this experimental? Use more students from other classes or schools and then randomize them not by classes. So those are two contributions.
So for this exercise, exercise 1, let me just also project it. Just give me a second. Okay, so I think there is a typo, so please excuse me. So the dependent variable is the rate, whether it's the smoking rate. It's supposed to be the drug rate. That's the dependent variable. That's what we want to see. We want to see if we put these people in this intervention and the other people don't get an intervention, how does the intervention affect the smoking rate or the use of drugs rate? So the independent variable there is the treatment group, if I can put it that way, because that is the variable that we are looking at. We are looking at if you are in the control group. So this variable is, we can also call it group or treatment group. Other people are in group 1, which is no treatment, and the others are in group 2, which is they get an intervention, which is a treatment. So it is one variable with 2 levels. One level is I didn't get a treatment. The other level is I got a treatment. It's the same as gender. Gender is a variable. You have male, you have female. So the independent variable there, we can call it group or treatment group. The independent variable is manipulated because some get a treatment, others do not get a treatment. It is not naturally occurring. We are giving a treatment to them. Me as a researcher, I give them a treatment, and I choose not to give the other ones a treatment. So I'm manipulating the independent variable in that way. Yes, there is a control group because there is a group that didn't get the intervention. The way the students are assigned, we can see that they just decided to take A, B, C, and D, E, F, and assign them in that way. So there is no randomization. So this is what is making the study a quasi-experiment. It is an experiment, but it is lacking one of the attributes of a true experiment, which is randomization. Can we make the study experimental? Remember, I said that if the study is a true experiment, we have enough evidence to claim a causal effect, meaning that we have enough evidence to attribute the smoking rates. If it decreases, we have enough evidence to attribute it to this treatment, to this intervention that we introduced. However, if we didn't randomize, then the causal effect, we don't have enough evidence for that because we're not able to ensure that our groups do not differ systematically. I'm happy that someone mentioned that in South Africa, I don't think it's still been done, but it was done, that you find that the classes are assigned based on your performance. So you find that if you are in grade 11A or grade 12B, you find that there are good students there, or you find that those are your science classes, your physics, your chemistry classes, and you find that your D, your E, your F, you find that it's not that those are not, but you do find that there are systematic differences. So those things can come into play and now mask the role of the intervention in how it's affecting the smoking rates. So I like that someone was able to pick it up there. Yes, we can make the study experimental. I think that was the response, one of the responses, by randomizing, by randomization, by taking, if we have A, B, C, D, E, F, we take all those students and then remember, okay, I used the example of putting them in a box and selecting randomly, but with a big sample, you wouldn't be able to do that with big numbers. There are there are functions. For example, Excel has a function where you can randomize. So you put your the list of your units. If it's those students, you put all of those students. If there are 300, you put them, and then you call that function in Excel to mix them up for you, to randomize them, and then you are able to select the first 50 or the first 150. You give them the intervention. The other 150, they get no intervention. But now you would have dealt with those systematic differences that might be there. I'm going to move on to exercise 2. So maybe I can get some of those responses for exercise 2, Tony.
Yeah, thanks. Some will also help me. Exercise 2, dependent variable eyesight of children under age of 10. Independent variable poor nutrition. The study would have to be done using quasi-experimental design because the dependent variable cannot be randomized, as it will be unethical to subject children to poor nutrition. Thus, the researcher would need to use available sample with no randomization.
Thank you, Tony. I think we will just tap into that response. Yes, I think the response is correct. The outcome variable here is eyesight. We want to see if eyesight is going to improve when the students get good nutrition as opposed to those ones who are. So as it has been mentioned, this is it's a quasi experimental design because yes, for ethical reasons, you wouldn't be able to subject the students to poor nutrition and give the other ones good nutrition. So you can only just, it's one of those studies where you can only observe the things as they occur. Yes, there is manipulation because the other one, then the poor nutrition and the good nutrition, you would be getting it from them. not actually putting them into groups. There is no randomization. You can't really randomize in this case, and you can't really do an experimental design. I want to wrap this up by mentioning that if we look at the experimental and the quasi-experimental design versus the observational studies, the non-experimental designs that we ended with, where I gave an example of a cross-sectional study where we looked at the prevalence of, I think it was gender-based violence. What you must take note there is you will have groups of people, but the treatment you get from them, you will be asking them, for example, if we use I want to go to the independent variables. The independent variables, you can't assign people to those independent variables. You observe them. So you ask them, what is your gender? So the independent variables are there, but you are not manipulating them in an observational study. You observe them. Another independent variable could be your income levels. So you will ask them, you observe them as they occur. You don't assign them to this income level, that income level. You can look at the area type. If literature suggests that some areas are more likely to have cases of gender-based violence as opposed to others. So those independent variables, they are there, but we don't manipulate them. We just observe them. So you ask them, and they will be telling you, this is I'm in this category of the independent variable. The other one is in that category of the independent variable. The same with the example that I gave of a longitudinal study, where we were looking at completion rate of your 3-year students who are registered for 3-year programs. You can't subject them to a treatment. So in the first case, where we were looking at a prospective, we were looking into the future with a questionnaire, you will still be able to measure the independent variable. You will still be able to ask them, for example, if they are attending some support programs on campus, maybe support for study skills, support for, there are many interventions that are offered by universities. So you are still able to see if they are on some interventions, which we can, for example, the example that I'm using, it can be support programs, but you are not assigning them. So I will have some students who are attending the library, the services that are offered by the library to assist you with writing, the services that are offered by student development to help you study skills, time management. There are some interventions there, but I'm not assigning them. I'm observing them. So other people will say yes, no. So I just wanted to bring that out to say the independent variable with an observational study, it's there. You just observe it. With an experimental design, you assign people. The question now becomes whether you are assigning them randomly or you are just assigning them without using a randomization. Thank you very much for the responses. I hope from the exercises you are able to link these studies and to be able to differentiate them and to be able to locate your studies. I'm going to proceed and move on to the second part of the workshop. So with a research design, it gives you the picture, as we've said. It's how are you going to arrive at the end point. So when you look at the research design, you have an idea of the methodologies that are going to be used throughout the study. Some methodologies are for sampling, other is for data collection. So if you're doing a truly experimental study, you might be able to see when the person explains the design, that this is how they're going to collect data. In this workshop, I am looking at the different designs, and I also decided to focus on the population and the sample. In another workshop, we can look at the questionnaire design, which is the data collection, how it's going to be collected. And then we can also look at how the data is going to be analyzed. So those things, they form part of your methods, which will they will be filled in with other methods. So in terms of your sampling, when you do a study, from, there is a population that you are interested in studying. And that population, obviously, it's based on your research questions, your objectives. They are the ones which are going to point you to where you are going to get data for these questions that you have. What is supposed to be your unit of observation or your sampling unit, if they are different. So a population, we can call it, it's a set of possible units of interest that meet the designated criteria of investigation. So you need to have a criteria to say, I am going to look at a population of young people. So my population will be young people. Is it nationally? If you are in South Africa, are you going to look at all the young people in South Africa? Are you going to look at a specific geographic area? So the units that meet your inclusion criteria will form your population. What will help you actually in having a correct identifying the population correctly? It's also correct definitions. I've mentioned that this, and I'm repeating it again because it's important that you clearly define concepts for your study, because they can be many definitions. And as I said, some of the definitions you might not be able to practically collect data using that definition as it is. So you might have to now go to an alternative, something that you can be able to actually measure. So your inclusion criteria specifies the units that are eligible to be included in the study, which is the target population, with the correct measures. So for example, if you want to measure health status, it has to be very clear. Is it emotional? Is it physical? Is it mental? Or is it inclusive of all of them? If your population is young people, for example, Statistics South Africa uses 15 to 35 years. In South Africa, those are regarded, young people within that age group are regarded as young people. But if you look at the UN, they talk about people in the age group 15 to 24 years. So where is your study located? If in your study you want to make comparisons with other African countries, for example, then it means your definition, you can't be looking at 15 to 35. You have to be looking at 15 to 24 years. So these things are the things that have to be clear at the beginning, because they will influence also, they will point you at your population, and then they will also influence your instrument of collection. So a population may be homogeneous, meaning that this population, it consists of elements which have similar attributes. And a population can also be heterogeneous, meaning that with regards to, remember, you must always remember that everything when we talk about it in research is in the context of your study. So they are homogeneous with regards to your variables of interest, or they differ with regards to your variables of interest. These attributes that I'm bringing out have an influence on how you are going to sample. So you will see how they come together. So you have a population that is your interest. However, it's not always possible to study the entire population. Also, it's not always necessary to study the entire population. We talk about if you are cooking in a pot, if you want to know if there is enough flavor, you don't eat everything in the pot, but you take a sample. If it's meat, you take a piece of meat. That sample gives you a picture about what is happening in the pot. So the assumption is where you are sampling, your sampling is going to be representative. So the purpose of sampling is to examine representative subsets of data with the purpose of producing estimates of parameters that are as close as possible to the true values. So if I were to study the entire population, that is usually called a census. If I study the entire population, yes, there will be some error, but if I'm looking at unemployment rate and I look at the entire South Africa without sampling, like they do maybe with the census, I think we are familiar with the census. The values that they get, they are the true values because they surveyed everyone. But if you do a sample, then you get an estimate from the sample. You want that estimate to be as close as possible to the true value. It should be as if I did a census, even though I did a sample. So my estimate should be as close as possible to the true value. So that is the sampling assists us in that way. We use a sample also because of operational costs. It might not be feasible for you to do an entire census. And also to reduce analytics and computing requirements. You find that if, for example, you're a student, the laptop that you are using or the SPSS, the statistical package that you are using to analyze your data has limitations because maybe you have a student version, so you are not able to capture 1 million records in that package. So that can be a reason why you are opting for a sample. But maybe you had money and you have all the reasons to go big, but maybe you have this limitation. And also some analytical techniques can take long with large samples. So a sample is supposed to be a representative with regards to the characteristics of the selected units. They have to be similar to those of the entire population. Then we are able to make inferences about the population based on the information that we get from the sample. When we talk about inferences, we are talking about my interest is in the population, but I'm going to look at a sample which is a representation of my population. What do I want? I want to take what I see, the picture that I get, the results, the estimates that I get from the sample. I want to paste them on the population. I want to make generalizations. I report as if I went to the entire population. So what I get from the sample, I paste it on the population. I say UNISA students are in this particular way. Whereas I didn't survey all of them, but I only surveyed. So I take what I got from the sample, I paste it on the entire population of UNISA postgraduate students. That's what we mean by inference. If the sample is representative, it improves the accuracy of the inferences that you are making. If the sample is not representative, what will happen is what you are observing from the sample is not a picture of what is happening in the population. So it's the example of in the pot, if you don't distribute your seasoning properly, and when you sample to taste, you will say the seasoning is enough or it's not enough. Whereas the problem was with your distribution. So it is very important that you go for, if you are going to want to make inferences about the population, you need to ensure that your sample is representative. We have two sampling schemes. We have a probability sampling or non-probability sampling. Before I continue, I just want us to just look at the concept of probability. So what do we mean by probability? Probability is the likelihood that an event, a particular event, will occur. And it assumes values between 0 and 1. So you cannot have, if something is a probability, it can't be more than 1. It will be 0 point something, or it will be 0, or it will be 1. If it's 0, it means that the chances of that particular event occurring is 0. And if it's 1, it means that the chance of that event occurring is certain. That event will occur with certainty. If, for example, for us who are in South Africa, if I ask you what is the probability that it will snow in Gauteng tomorrow, the probability is 0 because we never receive any snowfall. And then if I ask what is the probability that, well, if we assume it was full summer, what is the probability that the sun is going to come out tomorrow? Chances are the probability will be 1 because we're almost certain that the sun will come out in Gauteng. Another example is if you toss a coin. So your event that you are interested in, I said the probability is about the chances that a particular event will occur. So if you toss a coin, it's either you get a tail or you get a head. One event will be the head. The coin will land on the head, or it will land on the tail side. Only 2 events can occur there. So what is the probability that I will get a head? Because I only have 2 events, the probability that I can get 1 event is 1 over 2, which is 50%, or 0.5. Similarly, the probability that I can get a tail is 0.5. With this particular example, you can't get anything else beyond a head or a tail. If we go at the other example that is usually used, which is the example of a die. If I use 1 die, a die has 6 sides. So if I toss a die, it can either land on 1, 2, 3, 4, 5, and 6. So there are 6 outcomes that I can get if I toss a die. So what is the probability that if I toss 1 die, I get a 1? Because I have potentially 6 outcomes, it's going to be 1 over 6. What is the probability that I get a 6? It's the same probability. In this case, they have an equal chance of occurrence. They all have 1 over 6 chance of occurring. Similarly, with the other one, with the coin, they have 1 over 2 chance of occurring. They have an equal chance of, so there's an equal chance that I get a tail or I get a head. Similarly, equal chance that I get a 5, a 4, a 2, and so forth. If I toss 2 die, just to emphasize the concept, if I toss 2 dice, what is the probability that I will get a 2? I can only get a 2 if I get 1 die is 1 and the other one is 1. That's the only time I can get a 2. So it's going to be 2 over the possible number of the events that can occur. Similarly, if I toss a die, what is the probability that I toss 2 dice? What is the probability that I will get a 1? A total of 1, the 2 dice, the totals. That's what I'm referring to actually with these 2 dice. Even with the other one, a 2 is a 1 plus 1. In this case, it's not possible for me to get a 1 because there is no 0 on the die. So the probability that the total of the 2 dice after I've tossed them is 1 is 0. So that's how you are to look at it. But when we talk about probability sampling, bringing it back to the topic, is every unit has a known probability of being sampled. All the units of our population, they have a known population of being sampled. In most cases, they have an equal chance of being sampled. There is some form of randomization to ensure that the units have an equal chance of being sampled. If we go back to the examples that we were using of assigning your participants or your subjects to the treatment groups, once you randomize, any participant can go into the control or the treatment group. They have an equal chance of going into one of those groups. And the probabilities, they are assigned objectively. You are not influencing the assignment of the probability. On the other hand, with a non-probability scheme, which is also called a non-random sampling, the probability of selection is not known. So we don't know what is the probability of being in this treatment or being in the other treatment, because there is no randomization. The selection is based on subjective judgment of the investigator, as you will see later. So we don't have an equal chance if we are using a non-probability sampling scheme. Some people will have a higher chance of being selected than others. Non-probability sampling, the population does not have to be precisely defined. It doesn't have to be very specific. So it can be general. You can say, I want to study students. On the other hand, so for example, as I said, you can just say, I want to study university students. Everyone in the world can be an element of your population. It's general. It's got an infinite number of elements. It's not a problem because your sampling is not, you are in control. You can decide. It's a non-probability scheme. So even if the population is big, it's not a problem. With a probability scheme, sampling scheme, you have to be specific. You have to say, I'm only looking at students who are studying at UNISA, or I'm only looking at education students, master students, like that. I'm going to look at the examples of non-probability sampling. The sampling can be in a form of volunteers, where the participants volunteer to be in your study. So for example, if I wanted to do a study on something that concerns postgraduate students, I could approach all of you and you would indicate whether you want to participate or not participate. So you are participating voluntarily. Another option would be to use a convenient sample. So it's convenient to me as a researcher. So I could just decide that I will come on campus and go around the library, because maybe I'm more likely to find postgraduate students there. Go to specific areas where I know I'm more likely to find postgraduate students, and maybe do my study there. And if I'm using a questionnaire, most probably distribute my questionnaire there. So it's convenient for me. Sometimes you just send, for example, if it's like online, so you just send the invitation to everyone, but you only take who's going to, whoever responds. It's just convenient for you. You just take whoever is going to respond. And sometimes it's purposive. So I decide I'm going to select from this group. I could be informed by some reasons. I could be informed by the fact that this group has the attributes that I want to study. And then you can also use quota sampling. With quota sampling is when you are aware that here is my population, but my population is not homogeneous. My people don't have similar attributes. Even if I'm doing a non-probability sampling, but I'm aware that my population is not homogeneous. For example, I'm aware that males and females behave differently when it comes to exercise. Let's say the study is about exercise. So I am aware that males and females differ. They are not homogeneous with regards to this, my key interest, which is exercise. So because they are not homogeneous, I'm going to treat them as different groups and apply quotas. So I go to the gym. My sampling is still convenient because I'm going to interview whoever I find at the gym on that particular day. I'm going to go in the morning because it's convenient for me. And I think I'm going to find most people. But I apply quotas. So I want to ensure that as I distribute the questionnaires, I want to ensure that maybe I use a 50. I know that, let's say we know that 60% of the people who use the gym are males and 40% are females. It's just an assumption. So what am I going to do? I'm going to ensure that even though my sampling is purposive, I'm going to apply quotas. So I'm going to ensure that 60% of the people will be males and then 40% will be females, because I'm aware that there are differences and I'm aware this is how the population is distributed. So when I sample, I'm going to do that. At this point, we haven't discussed the issue of sample size. We're not going to talk about it in this workshop because the sample size, we use formulas that are available in research methods books, or they are available on, there are sampling calculators. So I think it's something that is best done. If you understand formulas, you can do for yourself, or you can request a statistician to assist you with the sample size. Now, what we are talking about is how you are going to sample. You know that I have to take 20. How am I going to get this 20? Here we are saying we are going to use non-probability sampling schemes. I'm here at quota. So it's going to be convenient, but I ensure that I meet the quotas of 40%, 60%. The other option would be to do snowball sampling. If I am studying something that it's not easy to get participants, I can approach the first participant, and then that participant can lead me to the other people they know who have those attributes. So you lead me to the next person, you tell me my friend can participate, then like that until I reach the required number of the participants, the required sample size that has been determined. The advantages is there is not much effort, as we have seen. It requires less time to implement, it's less costly. However, the disadvantage is you're going to introduce systematic errors. There is sampling, the systematic errors are going to introduce sampling bias. For example, if you are doing a study about brands, let's say you are doing a study about dishwashing brands, that is your study. You want to see the most preferred brands. You are in the marketing space and you decide that you are going to use a non-probability sampling scheme. You are going to use maybe a convenient sampling scheme within this group. And you decide to go, maybe you are only doing a region. So you are not doing a national study. And you don't want to do online. So you decide that you will approach these people at the malls, at the different malls in the region that you have identified as your study area. If you decide to go and collect and dish out your questionnaires in the morning, who are you going to find in the morning? Because people, okay, now it's a different case because we are working from home. I believe people have more flexibility to rearrange their days. But however, with a conventional life, with people who are gone back to the office, if you go to the mall, even with people working from home, I think we do respect our office hours. So if you go to the mall now, you are going to find here in South Africa, it's still in the morning. You are going to find people who are housewives, people who have retired, who are no longer working. Suppose so the sampling is biased because you are only going to find a certain group of people. It doesn't represent everyone who is using cleaning detergents, but it represents a certain group that when you went there, that is the group that you found. So it can introduce bias into the sample where your sampling is not representative. With the example that I used, if I asked you to volunteer to participate in a study where we are assessing how these workshops, if the workshops are efficient, if they are assisting you guys, and I ask you to volunteer to participate in the study, maybe I might find that people who are not happy are the ones who are going to be willing to participate, or the people who are happy are the ones who are more likely to be willing to participate. So there is bias there that is introduced. We cannot make claims about the representativity of the sample. So the inferences that you're going to make, because you collect data, you have questions there about brands, and you are looking at the relationship between brands, preference and income, brand preference and age, and what so forth. So you are linking things there in your study, but it's going to be difficult to generalize the results to the entire population because your scheme was biased, and in some cases you are not even aware that your scheme is biased. So we need to be careful with a non-probability scheme. It doesn't mean you cannot do it, but you need to try to manage this bias that can be introduced. In the example that we are using, you could go to the mall at different times and collect at different times so that you are able to reach different groups of people. So when you are using a probability sampling, your population needs to be specific. It cannot be general. In terms of the schemes, some of the schemes that are there that you can use. We have simple random sampling, which is the one that is mostly used. With simple random sampling, we all have an equal chance of being selected into the population. So I have a population, I have my grade 1 learners. With a simple random sampling, I take all the learners, I put them in a box, I shuffle, and I select 50, if 50 is my sample size. That is simple random sampling. There are no systematic differences there. I've ensured I didn't put people from poor families, people from everything is well distributed because of the randomization. Then you can also do a systematic random sampling. Systematic random sampling, there is randomness there. As you can see, it's got a random element to it, but there is also a systematic element to it. There are two aspects to it. The example that we can use is, suppose you want to study a particular, let's say, we go back to the example of gender-based violence, and you want to study it in a particular district within the country, or a particular district within the country. So what you can do, we assume that that district has got, you want to go to the households, you want to go to the houses. You cannot sample a house a household. Household, it's people. It's not a structure, but how the things are on the ground. You have structures. You have demarcated areas where from this point to that point, it's my yard. It's my dwelling. From this corner to that corner, it's my neighbor's dwelling. So that is how things are sitting on the ground. Yes, I want households. Households are the people in the house, but I can sample the structures. So what do? I need to obtain a list of all the structures that are there. Usually, if it's urban areas, there are maps there with house numbers. So you can really get a picture of all the houses. So let's say there are 600 houses there, and I want to select 60. This is just an example. So I can use a systematic sample where I decide, because I want to take 60, I'm going to skip 10 houses and go to the 11th house. So I want 60 and I have 600. So I'm going to skip I'm going to skip 10 houses and go to the 11th house. That will be the sampled house. As I say, you need to have a list. The list can be a map. The randomness comes in where am I going to start with my sample? Yes, I'm going to take 11, 22, house number 11, number 22, and so forth and so forth. But where am I going to start? You select a random start. So where you start, you don't decide. It's by randomization. So you take all those 600 houses, you ask Excel to produce random numbers for the 600 houses, and then you sort the numbers. Then the first number that you are going to get, if it's house number 20, then you are going to start at house number 20. Because you are skipping 10, from 20 you are going to go to 21. And then you skip 10, you are going to go to 22. So you skip like that until you get your 60 households. So it's systematic. You are skipping systematically. And then the start, you don't decide, I'm going to start here. There's a random start. You can also have a stratified random sampling. Stratified random sampling is similar to quota sampling in the non-probability scheme, where you are aware that your population differs with regards to some attributes of your study. So what do? You stratify because you want to ensure that, you have enough people in those stratas. So you form groups based on the variable that you are stratifying by. So if, for example, you're doing a study here in Gauteng, maybe it's about households, you can stratify by the municipalities, and then within the municipalities you can stratify by the area type, whether it's an urban area, whether it's a informal settlement, whether it's rural or it's tribal. So you make you stratify by those variables because you are aware that you want to have enough people within those groups, and you also want to make comparisons. You want to compare the urban with the non-urban, for example. So you must ensure that you have enough sample size in the urban. If you don't stratify, you might just find that you've got very few people in the urban and you've got many people in the other group. And when you have to do statistical tests, you don't have enough numbers in those groups. So stratification also assists you to ensure that if you want to compare by groups, you stratify in that way. The other option is cluster sampling. With cluster sampling, you select clusters. So I'm not sure if we are all familiar with how, the layout in South Africa, that we've got areas that we call informal settlements, where it's usually shacks, and they're usually highly congested, and there are usually no proper roads. And in most tribal areas, you find that the identification is difficult. There are no house numbers, because the structures, they tend to change very often, because now I have when I just have a smaller shack, then I get more material, I extend it. So we do have this informal settlements here in South Africa. So if I wanted to do a study in an informal settlement, a particular area, usually the characteristics of the people in that area are usually similar. The population is usually homogeneous. So because of the layout of that area, in order to do a probability sampling, you need a list. And you need a live list, an updated list that reflects the setup at the time you are doing the study. So with informal settlement, it can be very difficult to have a list, or it can be expensive. If you are doing it for yourself, it's not always possible. So, and the changes, they happen sometimes rapidly. So what you can sometimes do is you can go into the area and demarcate the area into small chunks. So if, for example, you want to select 10 households, or you want to select 50 households. So what you can do is you go into that area, you demarcate it into 10 clusters of 10 households, 10 households. What do you use to guide you? You use the parts, you describe the parts there. You say, from this corner of this pink shop, JJ's shop, you go straight, you turn around, this is my cluster. And then you form another cluster, you explain the cluster, that the cluster starts at this blue house or this blue shack, which is next to a pink shack, and then you go straight with the footpath, and then you continue until you get to a brick house, the only brick house in this area. So you try and explain the cluster by using the attributes of the houses and the footpaths and the other landmarks that are there too. So you do those clusters until you've clustered the entire area. So how many households do you want? We've said you want 50. And you made your clusters to have 10, 10, 10, 10, 10 on average. So what do? You take those clusters, you randomize, you put them in a box, and then you select 5 clusters. So instead of going to the house that are spread across the entire area, you only go to 5 clusters. You can only do this if the people there, the households there, have similar attributes, because I'm saying this cluster is a true reflection of the other clusters. So I take 5 of them. They are a true reflection of the other clusters. This is different to random sampling, where if I had to use simple random sampling in that area with 500 households, the simple random sampling will say, go to house number 1, number 35, number 45, number 18, number 90. So the houses are spread. you find that sometimes they are far from each other. I have to be going to those houses. With the cluster sampling, when I go to this cluster, these houses are close to each other. I collect from the cluster. I move on to the next cluster. So it's more efficient in that way as opposed to doing a simple random sampling where the houses will just be spread across the entire area. With cluster sampling, I go to the cluster, everyone in the cluster, I do my study with you. I go to the other cluster, so I'm not all over the entire area. And I don't really need that because these people have similar attributes. I can just select some clusters to represent them. The other one is multi-stage sampling, where you sample at different levels, where let's say your study is about learners. So you can sample schools, that's one stage of sampling. And then within the schools, you sample learners. That is another stage of sampling. That is a multi-stage sampling design. The advantages is you are going to reduce the chances of systematic errors. That is with a probability sampling. Sampling bias is reduced. The sample will be a better representation of the population, and the inferences, you can make the generalizations. However, more effort is required, time consuming and expensive. For you to do that, I think if this scheme could be done, most people would do it. However, for you to do a probability sampling, you need a list of the units. As you see, as I explained the different schemes, even as we use the learners, we have the list of the learners. With studies where it says the national studies, okay, even if it's not a national study, where you want consumers, you don't have a list of consumers. So that's why sometimes you'll go for a convenient sampling approach. And then as to implement it, it's expensive. However, the selection of the approach that we are going to use will be guided by your research objectives. The design. So you need to have a sampling frame for you to be able to do a probability sampling approach, which is a list of all the target population members and the attributes. So you need to have a sampling frame. If you are going to do small, medium enterprises, you need to have a list of those enterprises if you are going to do a probability sampling approach. And the list has to be well maintained. It must have all the businesses that are active at that time. So there has to be, it shouldn't be a mismatch. The list and the population, they have to match properly. You shouldn't find that on your list you've got enterprises that are no longer operating, or you have new enterprises which are not there on your list. So the list has to be properly maintained. You need to, it must be clean, and you must not have duplicates. Otherwise, you are going to sample one enterprise more than once because there are duplicates on the list. And I want to mention that the sampling scheme, when you're using probability sampling, you don't always, the probability doesn't always have to be equal. There are cases whereby we want some units of the population to be included with certainty. As I explained, with certainty, meaning their probability of inclusion is 1. For example, if you are doing a survey on businesses and you are using the business register, which is housed at the South African Revenue Service in South Africa, and you have that list, they have a list of businesses that are registered for tax, and you want to use that list. That list is maintained, so they have businesses that are active, new ones, and so forth and so forth, as I've explained that it needs to be maintained. Because we know that in terms of revenue, remember the enterprises are divided into the size based on the revenue that they are making. We've got small businesses, we've got medium, we've got large or big businesses. So the big businesses are the ones that are making a lot of revenue in our country. So in some studies, you will say that I want all those businesses, the big businesses, I don't want to sample from that group. So you will stratify by a size. Then you will have the group, I will sample from the group of the small ones, I sample from the medium, and I sample from the large. From the small and the medium, I will have a quota that I want 20%. I've stratified and I've allocated. The quota can be proportional or it can be non-proportional. Proportional, it means that if 40% of the businesses are large, then my sample must have 40% of large, no, not large, but medium. And if the small ones are, as they constitute 60% of that population, then my sample must have 60%. That is proportional. My sample is proportional to the population size. However, in that other group, I take everyone. So all the businesses are sampled with certainty. They have a probability of 1. But in most cases, we do use simple random sampling where we all have an equal chance. But I'm just giving you an example where there are cases where the units don't have an equal chance. Yes, we know their probability of being sampled. With the big ones, we know their probability will be 1. With the other ones, it can be determined based on the sample size and what we've taken. So the probability is known, but it is not, in the other case, it's with certainty it's 1. With the other one, it's not 1. It's between 0 and 1. So let me just, I'm going to ask Tony to assist me from here. This brings me to the end of the presentation. Because the proposals came after the break, I'm going to ask Tony to request you to post your questions while I look for a proposal that we can use for the exercise that I have prepared, just to incorporate all the things that we have discussed from the design to where we are at the sample level. Over to you, Tony.
Yes, thanks. There were questions that were coming, and yeah, they were also asking about the proposal. I'm glad that you have touched it. With the questions, maybe let me start with the general ones. Okay, to Leboga Moabi and Makotla, we have noted your concerns. We will attend to them. Yeah, Princess, Lizelle wants to know about the procedure to consult.
Okay, the office is still new, so at the moment you can just send an email to myself. I think they will share it on the group. In future, there is a form. I think it will be ready by next week, which you will have to complete. The form has issues about the supervisor and all those things. But at this point, you can just send an email, and then I can send you the form if it's ready. Otherwise, I'll just you explain what you need assistance with, and we take it from there.
Yes, I think an email will do, because I think she's in Ethiopia, if not mistaken.
Okay.
Yeah, and there's another one on the follow-up workshops on statistical analysis, data collection, and I must confirm that there will be workshops, and I believe we will share the schedule with them shortly. Now, regarding the presentation, the Makato wants to know how you go about determining sample size when using snowball sampling method.
Remember, the sample size, we estimate the sample size based on the population size. So very important when you do your study is you need to know the population size. Even if you don't, it's an estimated figure, but you need to have an idea of the population size, whether you're going to do a convenient sampling or you're going to do a probability sampling. So the other thing, one is the size of the population. Two is the whatever you are measuring. We look at previous studies to see what was the level. I'm assuming we are talking about surveys. The question is about surveys. So we look at if whatever you are measuring, what was the level that was identified by previous studies. We use that as an input to determine the sample size. And we also look at the margin of error at the margin of error. If we want to be 10% certain, 5% certain that this thing that we've estimated is between this level, and that those are the things that we look at. So what I've said is usually I would advise, if you are not familiar with formulas, it's better to consult a statistician, and then they will be able to ask you questions which are going to guide the statistician to determine the sample size for you. If you are studying something that is very common and you understand formulas, you can use those inputs that I've mentioned and plug them into a formula, and it will estimate the sample size for you.
Thank you for the response. Now we have one from G Storm. They want to know which of the quantitative research designs would you suggest for a mixed method design? The initial thought is that the non-experimental design could work very well to substantiate qualitative research. And I think this also responds to the question raised by Petros. Thank you.
I think it depends, actually. It just depends on the research question on the quantitative aspect. It depends on the research question on the quantitative aspect and the variables, where the variables are located. You can't really say that because my study is mixed method, I must use a true experiment, or I must use an observational study. It will depend on the research questions. As I have explained, for example, if you are going to do a survey, it's observational. There is no treatment there. You are just going there, giving the people, unless there is an intervention. So you see, as I move, it depends on what you want to establish. If you want to establish prevalence, you want to describe a phenomenon in a population, you will use a survey to do that. So I'm arriving at a survey because I say, this is what I want to do. I want to describe, I want to look at prevalence. That's why I'm doing a survey. Now, on the other hand, no, my study, we want to look at the effect of some intervention we are doing. So what do? I'm going to do some form of an experiment. So it means I'm going to a quasi, because I'm going to manipulate the independent variable. So I moved from the objectives. I want to compare some treatments, or I want to compare things that are naturally occurring. So I'm going to observe. I'm not going to give a treatment, meaning I'm going to observational. So I think that's where we have to be clear. The direction is given by the objectives and the feasibility. I mean, with the example that I gave of anger, if let's say you can do a proper experimental design with that scenario, if you wanted to look at teenagers, how certain environments induce anger in them, so you can put them in what you can take them and put them at your lab, a psychology lab there, and put them under certain stressors and measure. So you can do a truly controlled experiment. So as much as, for example, the objective was to look at anger levels, another researcher might be looking at anger levels, but they might not have access to a lab. So they don't have money also for the apparatus to measure your voice. So they are limited. Yes, they wanted to measure the same thing, but they can't measure it as the same way as the other researcher because they don't have that. So they have to use maybe a visual analog scale, or they have to use these questionnaires that are validated, that are used to measure anger, meaning they are going to do a survey. It's a cross-sectional study. It's observational. The other person was doing a true experiment. So I hope you see that it's driven by certain things, but not just to say it's quantitative, therefore I must use this technique.
Thank you. We have one from Liesel. She wants to know, her question is, do all your measurable variables need to be known before collecting your data and build into your instrument? And the follow-up is, can measurable variables emerge during data collection?
Okay, yeah, this is the difference with I'm not an expert in qualitative, and yes, but this is one of the differences with a qualitative approach where new things can emerge as you are studying. With the quantitative research, because it's structured, you can't let things to be emerging. Remember, you have a questionnaire, and the questionnaire, when it's approved under this design. And what we know about this design is, here is the questionnaire. Me as a researcher, I've satisfied myself that these are the variables I want to measure. I can formulate or recompute other variables from the ones that I've already collected. But I can't create, everything must come from this data that I've collected, if I can put it that way. Because you can recompute, for example, in the questionnaire, you can have, you can ask people about your income, your age, and you can ask it, maybe they give you the actual age, as in 25 years. And then when you go and do analysis, you realize, no, actually for my study, this data needs to be in categories. So I just repackage that variable into categories, that age variable. Or I can compute another variable that takes into account age and income, or age and education. Then I have my variable. But that thing, I planned it, that this variable, I'm going to get it by taking this variable and doing this to it, and then I get this variable. But it must not emerge when you are collecting data. No, you have to be clear about all your variables, because you have to even know how you are going to analyze the data before you even do data collection.
The next one is from Itumiling. The question is, those variables that mask the true results, can those be categorized as stochastic terms in the equation, depending on the method and modeling used in case of quantitative analysis?
I'm not familiar with the concept of stochastic, so it's it's difficult for me to respond. I'm not familiar with it. All I know is, if you are doing a true experimental study, those variables, they tend to be covered by randomization, because your units, they don't differ systematically. If you are doing you are doing a quasi experiment, or if you are doing a survey, that's why even if I want to measure alcohol use, I don't just put questions about alcohol use there. I also put questions about the things that I know are related to alcohol use. So those variables, in that way, I want to control for those variables. You can only control for them if you are aware. So you first control for them. So if you can't randomize, if you randomize, you don't have to collect them. You don't have to measure them. But if you don't randomize, you have to measure them, and then you control for them in the statistical analysis. They are included in your model when you model whatever outcome you want to model. So I hope I'm close to what they meant.
Yeah, thanks. I hope Itumeleng will respond. This one, they need a confirmation. Can they use non-probability sampling method like purposive sampling for a quantitative study?
Yes, you can. I mean, as I explained, we all, in the ideal world, would all want to use probability sampling. But as I've explained, you need to have a list for the units. If your population consists of what? CEOs. So if your study is about CEOs, you have to have a list of the CEOs for you to do a probability sampling approach. So if you don't have a list, you can't do a probability sampling approach, which means you have to use a non-probability approach. But when you do the non-probability approach, you must be aware of the biases that can be introduced and try to manage them. As I explained with the example of going to collect data at the malls, that you go at different times. I know even people in the tourism, they like to ask people, visitors to different tourist destinations, about their experience, about what motivates them to go to those destinations. So they also have to go at different times to minimize the bias, to ensure that they don't only go during the week where it's maybe sometimes students. So they have to make sure that they even go on weekends, they go on off-peak, or peak, times, to ensure that you minimize bias by just having a particular group of people because of the nature of the way you did your convenient sampling. Here is a proposal from Anonymous. I didn't check the name. So let's just go to the objectives. I will read them as they are stated here. I hope we'll manage. We have 10 minutes. So the title is State of Employee Engagement at Free State Provincial Treasury. So this person is going to do a study at the Free State Provincial Treasury. They want to measure employee engagement at this particular place. So the population for this study is it's this unit that is mentioned here. And looking at the topic, I'm not able to see the specific objectives, but by just looking at the topic, you can already see that the researcher is going to do a survey. So I'm here. I was not able to see the section on the objectives. No, now I'm on the research design. By looking at the topic, I already see a survey. That is what I'm expecting in this section here that I'm showing you, because employee engagement, you have these questionnaires that are used in that space, in the HR space, which are used to measure employee engagement. And employee engagement is a construct. It's one of those variables that you can't measure directly. Like, for example, you can measure gender. With gender, you ask me, you subject me to that question, you've got male, female, other, I respond appropriately. So you can measure it directly, that variable gender. You can ask me how old are you, I give you my age. You can measure it directly. But with an employee engagement, you find that they have, it's a construct variable. You can't just ask one question and you have employee engagement. So what is usually done in those studies is they have several variables. So for example, I'll give you an example like job satisfaction. This is another variable in this space of HR, where you are, if you want to measure job satisfaction, they will ask you several questions. Are you happy with your pay? Are you happy with your benefits? Are you currently looking for another job? Do you see yourself in this company in the next? So these questions that I'm listing are indicators of job satisfaction. So even in this study, they will be taking that approach. So what we see from the second paragraph, we can see the researcher is saying when they were preparing the proposal, there are 402. The employment report for this month in October, there were 402 employees in this entity. And then 330 are in salary level 3 to 12, which is deputy directors. And then the rest are lower levels. So they're trying to give us a picture of the population, which is supposed to assist. So they are also explaining they are excluding senior managers. If you read the senior management employees, which are they amount to 32, they are excluded from the study. So from 402, now they are sampled. So they are mentioning the exclusion criteria that we are going to exclude this number because they are responsible for this thing that we want to measure. Okay, so meaning their population is going to be 370. So now I want to see the sample size is not there. So this proposal is not telling us how many people they are going to use for their study. They are not telling us if the employer is going to give them, let's say, the data collection. What does it say? So what are they going to see? They're saying they're going to distribute the questionnaires. So the participants are going to administer the questionnaires themselves. So what is missing there is the sample size. And it is not mentioned whether it's going to be probability or not probability sampling. So by the look of things, it's a non-probability sampling scheme, which maybe is going to be convenient. Yeah, that's all what that is being mentioned there about the methods that they are going to use. So you can see that this section it's very thin on details on how this study is going to be done. Yeah, it's very thin on how this study is going to be done. I'm trying to. So when you don't know the phenomenon, like when you don't know, because they are measuring employee engagement, when you don't know the levels of employee engagement, you don't have a reference. We usually use 50% to compute the sample size. I'm trying to do the sample size. Just give me a second. So Yeah, so I'm trying to do the sample size for them because we don't know the employee engagement. I said 50%, that's what we usually use when we don't know. And then the population size is 370. And then the estimated sample size for this study is 189. So with 189, we are 95%. I'm using a 95% confidence interval. So we are 95% sure that if we were to repeat the study, this study, many times, here with the sample of 189, so I do 189 randomly, do the employee engagement, measure it, take another random sample of 189, measure employee engagement. I do it many times. I am confident that 95% of the chance I will be at the true value. There is that 5% of error. So I'm 95% confident that the number that I'm going, the level of engagement that I'm going to estimate will be will have a 5% margin of error. So it's more about if I do this study many times, replication, I'm confident that 95% of the time I will be within this range in terms of my estimation. When you estimate, you are going to have a confidence interval, which will be a number where the true value of the employee engagement is going to lie. So we are saying if I do my study many times, remember when you do the study many times, you approach the true value. Because as I sample, this time I sample Samo, next time I sample Tony, next time I sample Emma. So if I sample many times, I end up having sampled everyone, even though I was doing it in 89. This is just to explain the concept of being confident that 95% of the time, my estimated level of employee engagement will be between the confidence estimate that I'm going to get when I do the analysis. Yeah, that's the best I can do. But I just want to show you that, for example, the shortfalls in the proposal, it's not mentioned the sample size. And also the 370, they are grouping people who are not similar. 3 to 12, those people are not similar. That grouping is not homogeneous at all. You can't compare someone who's on a level 3 and someone who's a deputy director with regards to this attribute. I don't know, maybe they've motivated that they don't differ with regards to this attribute, but on a face value, I could be wrong. Just looking at it on the face value, you can't group, the people there are not really similar with regards to the attributes, even though they still have low level, but 3 is still low level compared to 12. I mean, at level 12, you are almost a senior manager. You are approaching the ceiling, towards the ceiling of government and management. So you can't be compared with someone who's not even a manager, who's, yes. So if it was me, I would advise them to take, for example, post level 8. I think that's where assistant director starts at government. So maybe they can take post level 8 and 9, I think, and 10. Those are assistant directors, and combine it with 11 and 12, which is deputy directors, and then take these other people who are non-managers. So you still have your level 3 to 7, still level 3 to 7, and the lower end, which is not outlined here. So the grouping here, it's not good. And because they've stratified in this way, we also expect quotas if they are using convenient sampling. They should be able to say, in this group, this is the population size. In this group, this is the population size. And therefore, I'm going to ensure that in my sampling, I have 40% in this group, 30% in this group, and 40% in that group, because this is how the population looks like. So those are some of the things that are not clear that you can learn from this proposal. As I said, it's cross-sectional. The person is going to go there, the people are going to respond, and you've measured the outcome which is employee engagement, and also you've measured the other variables that are associated to employee engagement. And then you can continue with analysis. Yeah, I think the time is up. I could only do this question, this proposal.